Dear all, this lecture is dealing with the condition for reciprocity and symmetry of a two-port network in terms of Z parameters. Okay, so this is a condition related to Z parameter. Condition for reciprocity related to Z parameter. So you know reciprocity theorem. Okay, so according to that theorem, a network is said to be reciprocal if the ratio of excitation at one port to the response at the other port is same if the excitation and response are interchanged. Okay, so I'm repeating. According to reciprocity theorem, a network is said to be reciprocal if the ratio of excitation at one port to the response at the other port is same if the excitation and response are interchanged. Okay, for example, here I am considering a two-port network. So this is a two-port network and I am having my input port here, and I am having my output port here. So I am taking the condition 1. So I am taking case 1. So in case 1, I am going to consider the excitation at the input side. So this is my excitation that is connected across the input port. Let Vs be the voltage of this voltage source, and I have the equivalent current as I1. And the second port I2 is the second port is there where current is I2, and I have shorted this particular two terminals for getting the load current I2 dash. Okay, so here this is the case. My excitation is at the input side. So excitation is at the input side, that is Vs, and the output or the response is at the output side, that is I2 dash. So response is I2 dash and excitation is Vs. So Vs is connected to the input port and I2 dash is taken from the output port. Now how I can write this equation is, here actually V1 is equal to Vs because Vs there is no resistance here. So the voltage across the two terminals, that means I and I1 dash of the port 1 is same as the input voltage Vs, and therefore V1 can be Vs itself. And I have short circuited the output terminal, that means my V2 is equal to 0. So V1 is equal to Vs and V2 is equal to 0. And one more thing, I can write that I2 is the current that is flowing inward from the output port and I2 dash is the load current. So from the circuit, since there is no impedance in between I2 and I2 dash, I can write I2 dash is equal to I2. It's I2 dash is equal to minus I2, or I can write I2 is equal to minus I2 dash. Okay, so from this I can rewrite the equation. The equation representing Z parameters are V1 is equal to Z11 I1 plus Z12 I2. Let it be equation 1. And the second equation is V2 is equal to Z21 I1 plus Z22 I2. Let this be equation number 2. So these are the equations that are representing the Z parameters. Now from these two equations, that means from 1 and 2, I need to consider the conditions. I need to substitute these conditions in these equations 1 and 2. If I am doing so, I can write the first equation changes to V1 changes to Vs. Vs is equal to Z11 I1 minus Z12 I2 dash. And the second equation changes to 0 is equal to Z21 I1 minus Z22 I2 dash. Okay, so this let be equation 3 and this equation be equation 4. And from the equation number 4, I can solve for I2 dash. Okay, or I can solve for I1. So I can solve for I1. I1 is equal to Z22 by Z21 into I2 dash. So from equation 4, I can solve for I1 is equal to Z22 by Z21 into I2 dash. And substituting this in equation 3, substituting the same quantity in equation 3, I can write Vs is equal to Z11 into Z22 by Z21 into I2 dash minus Z12 into I2 dash. Or I can write my Vs by I2 dash is equal to Z11 Z22 minus Z21 Z12 divided by Z21. So this is the ratio of excitation and response if the excitation is connected at the input side. Okay, now I am going to take the second case, that is case 2. here I have the same two-port network, and I am connecting the excitation at the output port. The excitation is at the output port, so Vs is here, and here you have the current I2, and I am taking the response from the input port. Okay, so response is what? Response will be I1 dash, since the current at this particular port is I1. So this is the same two-port network that I have used for case 1. So here how I can write is, I can write my Vs as equal to what? V2, or V2 is equal to Vs, and my V1 will be equal to 0, and I can write one more thing, I1 and I2 dash are flowing in the opposite direction, therefore I1 will be equal to minus I1 dash. So these are the things that we am getting from the figure. So here also I am taking the same equations, V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay, so let this be equation number 1 and this be equation number 2, and substituting these conditions in these equations 1 and 2, the one from 1 I will be getting V1 is equal to, that means V1 is 0, so 0 is equal to minus Z11 I1 dash plus Z12 I2. Okay, and equation 2 becomes Vs is equal to minus Z21 I1 dash plus Z22 I2. Okay, so I am getting equation 1 and equation 2 like this. Let this equation be equation number 3 and this equation be equation number 4. And from 3 I can solve for I2. I2 is equal to Z11 divided by Z12 into I1 dash. Okay, substituting the value of I2 in equation 4, I can solve Vs is equal to minus Z21 into I1 dash plus Z22 into Z11 divided by Z12 into I1 dash. Okay, so from this equation I can write Vs by I1 dash is equal to Z11 Z22 minus Z12 Z21 divided by Z12. Okay, so I am getting Vs by I1 dash is equal to this, and Vs by I2 dash is equal to this. So if you are taking this equation and this equation, numerator of this equation is same as numerator of this equation. Both are Z11 Z22 minus Z21 Z12, and the denominator of this is Z21 and denominator this is Z12. So for making this circuit valid for reciprocity theorem, you should have V1 by I1 dash will be equal to Vs by I2 dash. These two ratios should be equal. If these two are equal, we can write the numerator of this will be equal to numerator of the previous thing, and denominator will be equal, and therefore I am getting Z21 is equal to Z12. So this is the reciprocity condition of a two-port network in terms of Z parameters. If Z21 is equal to Z12 or Z12 is equal to Z21, then that network is said to be reciprocal in terms of Z parameters. So that is a condition for reciprocal. Next you have to study about the condition for symmetry. So what is a condition for symmetry, or for a network to be symmetrical? The voltage to current ratio at one port should be same as the voltage to current ratio at the other port with one of the ports open circuited. So I am repeating, if one of the port is open circuited, then the current to voltage ratio at one port should be same as the voltage to current ratio at the one port should be same as the voltage to current ratio at the other port. And this is a condition of symmetricity. So first of all I am taking like this. The first condition is I am making I2 is equal to 0. That means for checking symmetry you need to make one of the ports as open circuit. So I am making I2 is equal to 0, and I am making I2 is equal to 0, and I am taking the equation. I am getting the first equation, that is V1 is equal to the source voltage, that will be equal to what? Z11 I1. I2 is equal to 0, so second term will be equal to 0, and from this I can write Vs by I1 is equal to Z11. Okay, so this is the ratio of voltage to current in port 1 if port 2 is open circuited. So here port 2 is open circuited. Port 2 is open circuited, and this is the voltage to current ratio. Voltage to current ratio at port 1. Now I am taking the second condition, the condition B. I need to make the port 1 as open circuit. That means I have my I1 is equal to 0. Port 1 is open circuited. Port 1 is open circuited. Now from this port 1 is open circuited, I can write the equation, second equation as my V2 will be equal to Vs, the supply voltage, that will be equal to Z2 to I2. And from this equation I can write the ratio between Vs and I2 is equal to Z22. So this is actually the ratio between V and I at port 2. Okay, so this is the condition. For case 1, I am making I2 is equal to 0. I2 is equal to 0 means I am connecting the source voltage here and this circuit is open circuited. Okay, so I am getting I2 is equal to 0 and I have the ratio between Vs and I1, and that is represented by V1 is equal to Z11 I1, and from this ratio I am getting V1 by I1 is equal to Z11. And in the second case I will be making the input port as open circuit and output port I am connecting my source. So Vs is here, I have my I2, and here I1 is equal to 0. So here I1 is equal to 0. If this is the case with input circuit, this circuit means case 2, then I can write my V2 is equal to, V1 is not there, so V2 is equal to, Vs is equal to Z2 to I2. Then I can find the ratio between voltage and current as Vs by I2 is equal to Z22, and this is the voltage to current ratio at port 2. Now the condition is if the network is symmetrical. If the network is symmetrical, then Vs by I1 in the first case will be equal to Vs by I2 in the second case. If these conditions are satisfied, what will be the condition is, if this ratio, that means if this ratio is equal to this ratio, I can write Z11 is equal to Z22. So this is the condition for symmetry. Okay, so condition for reciprocity is Z12 is equal to Z21, and condition for symmetry is Z11 is equal to Z22. So these are the conditions of symmetry and reciprocity in terms of Z parameters. Thank you.